this is the last video of this week, so you don't have much slides, but this is an important subject, so I just thought that this concluding subject needs its own clip on its own. So guys, as I told you, we have covered some techniques on co-design. What is co-design? You have neural networks, they are interconnected. There are so many connections, and we have realized that not all connections are important. That's why we do pruning. Then instead of doing it in activations wise, just like we do in our human brain, we have tried to design techniques. All these techniques are handcrafted, guys. People sit, very important engineers, very valuable scientists sit, and they think, okay, there are so many connections here. Let's put this architecture like this. Let's put this architecture here. It will be more efficient. Let's try it. So it's like a handcrafted trial and error thing. Guys, when I talk about deep learning, I always tell you this. Before deep learning, the features were handcrafted, which means there's an image, you collect edges from the image, then you apply machine learning to those features. The features were handcrafted. The age of handcrafted features died with deep neural networks, because deep neural networks automatically found necessary features for them. So handcrafted features died with deep learning. But now we're trying to handcraft the architectures. Well, what if we could find an architecture in which the deep learning architecture would find its own architecture specific to the problem, just like it is in our brain. So maybe we should find a mechanism for the deep learning to find its own architecture. So maybe that's the next big thing. And actually, it is the next big thing, and it's called the neural architecture search. Instead of co-design, researchers within the last few years, like last 2 years, trying to automatize this operation. They're trying to make this automatic. Deep learning closed the area of handcrafted feature design. Now they create features from the data on their own. So why not do the same idea, this time applied to co-design? Creating co-design from the data according to its accuracy and its problem. So let's remember the big picture. Do you remember we have covered most of the classification networks here? So MobileNet, ResNet, ShuffleNet, GoogleNet, ResNet, bigger one here, DNNs, I mentioned about it, ExceptionNet, Rand's Next, we have mentioned about it. Many networks of VGGs and AlexNet, almost all of them, most of them we have covered. And there's this one here, guys, the best one, NASNet A large. NAS stands for Neural Architecture Search, guys. It's a very recent paper, and when you do the architecture search on your own, you have so much operation, but you get the best accuracy. So by handcrafting, we cannot find the best accuracy, guys. It must find its own way, but still there's so much operation for it. So using neural architecture search, just like VGG was around here and it moved to here, we are at the start here. This graph will move somewhere to here, guys, by neural architecture search. So I strongly recommend you guys who are going to work on deep learning on their masters and PhDs. This is one of the next big things, guys. It combines neural networks, recurrent neural networks, genetic algorithms, and embedded architectural deep neural network. It's very important, and I strongly recommend you to work on this subject. Okay, we're going to talk about this subject, neural architectural search, architectural search networks, in the following week. So don't worry. So take good care of yourselves, and see you next week then.